In this video, we will talk about payoffs that are feasible and payoffs that are sustainable. Let's start with what we mean by feasible payoffs. So these are payoffs that could be generated in this game, like think of average payoffs over time as delta goes to 1. So an average discounted payoff as delta tends to 1. Okay, so think that if these players always play 1-1, they always play defect every single period. So remember, this is the payoff matrix. C, T, 2, 2, 3, no. 0, 3, 3, 0, 1, 1. If they always play defect every single period, then they both would get 1-1, right? And if they're playing it every single period to infinity, then as delta tends to 1, basically their average discounted payoff will be 1 for player 2 and 1 for player 1, right? Similarly, if they always play CC, it's late in the night and I can't seem to draw straight lines. If they always play CC, then they can sustain an average discounted payoff of 2-2. We're not talking about what is equilibrium here. We're just saying, suppose they play that. Could they sustain that average? Could they get that average outcome? And yes, they could get an outcome in which both players are earning 2. They could also earn an outcome in which player 2 is always earning 3 on average and player 1 is earning 0 on average. If, for instance, they keep playing, player 1 keeps playing C while player 2 keeps playing D. That's definitely not equilibrium, but it is feasible, right? Given the payoff, given that payoff matrix, they could make that happen. We will get to what is sustainable as an equilibrium. For now, we're just saying what is possible. This is also possible, right? Where player 1 earns 3 and player 2 earns 0 on average. Let's just connect these. So here, it's easier to keep in mind we're talking about what's possible versus what's not possible. So for instance, it's not possible for both of them to earn 4 on average. It's just not possible. It's also never possible for both of them to earn half on average. It just wouldn't work. There's no way of choosing actions such that both of them earn 1/2 on average. So we're just talking about what's possible. If you choose the ratio with which you play 1-1 versus with which you play DP that gives you 1-1 and with which you play CD that gives you 0-3, if you play 1-1 half the time and CD half the time, then you can get to this point. But you could split that ratio pretty much any way you want. And so you are able to sustain everything that is on this line as a possible average payoff. All you have to do is choose the ratio with which you end up here to here, right? If you end up here more often, then you're closer to this point. If you end up here more often, then you're closer to that point, right? That's the notion of a convex combination. Everything that's a convex combination of these 2 points is possible in equilibrium. Similarly, it is possible as a payoff, not an equilibrium. It's possible as a payoff. Again, it is late in the night and I misspoke. Similarly, holds for these, everything between these 2 points, holds for everything between these 2 points and these 2 points. You can sustain, you can have these payoffs be possible as a function of that payoff matrix. but then also these 2 points. You can also play this strategy half the time and this strategy half the time and get everything in between here. And so that holds true for everything over here within this diamond shape. Now all of these are possible outcomes given the payoff matrix. So all you have to do is choose the actions carefully and you can get pretty much everything that is in here. To be clear though, you will only be able to get rational numbers here. So any number that's irrational, so let's say the square root of 2, 1.414 something, it's an irrational number. Square root of 2 is achievable as a feasible payoff, but we would never get exactly that. We can approximate it, we can get arbitrarily close to it. We won't get exactly there, but nobody's worried about that in this course right now. So everything, as far as we're concerned, everything within this diamond shape is possible given our payoff matrix. Now, let's get to the more interesting question about what we can actually sustain in equilibrium. And it turns out that we can sustain everything that is above this. So what we can sustain is this, up to this diamond. And the way it works is this. Let's say you and I are playing this prisoner's dilemma game. Okay? And we want to sustain, for instance, this point. Then what you have to tell me is, or actually let's keep it even simpler. Let's look at this point where both of us earn 1.5, 1.5. And the idea is this. What you're telling me is you keep playing this strategy that gives us 1.5, 1.5 on average, because if you don't, then I will deviate to never cooperating with you and both of us will earn 1 and 1 forever. So as long as what you're promising me is greater than 1, or at least as much as 1, I am willing to just follow whatever strategy works for you. So it's like a grim trigger strategy, but it's a grim trigger if I ever deviate from the plan that gives us this number or this number for that matter in those combinations of payoffs. So for instance, one thing that works is, let's say you tell me that we will always be switching between CD and DC. Right, so one period we get this, one period we get this, and then we just keep switching back. On average, we end up with 1.5, 1.5. Fine, because like half the time I'm getting 0, half the time I'm getting 3. But I'm okay with that, because I know that if I ever deviate from that, then we will end up at 1, 1. And if you believe that if you ever deviate from this, then I will punish you, and we will end up at 1, 1 forever. And both of us have these mutual beliefs that unless we play this weird game, then we will end up at 1, 1 forever. Then that is sustainable in equilibrium. Both of us have an incentive to follow that strategy rather than to deviate from it, given our beliefs. And because we will never deviate from it, and this is never actually realized. And so our beliefs will never be contradicted. Okay? So anything that is in this purple shaded area is sustainable, it is feasible. So it's possible given the payoff matrix, because it's part of that green diamond, but it's also sustainable in some Nash equilibria. And we can have lots of Nash equilibria here, because and the way we enforce those Nash equilibria is by having players believe that unless they play those strategies, that they will end up at 1, 1 forever. Okay. That's the last video for today. We'll see you hopefully in the Zoom lectures tomorrow.